A p-type semiconductor has acceptor level 57 milli electron volt above the valence band. Find the maximum wavelength of the light which can create a hole. So here this is the valence band and this is the conduction band, right? And when the electron excited, it becomes or jump to the conduction band, and the deficiency of that electron will have the hole. So that much energy is required, 57 milli electron volt. So the energy, that is h nu should be greater than or equal to 57 milli electron volt, and we have to find the wavelength. So h c by lambda greater than or equal to 57 milli electron volt. So lambda is less than or equal to hc by 57, that is inequality, hc by 57 milli electron volt. And in place of hc we can write the 1242 electron volt nanometer by 57 milli 10 to the power minus 3 electron volt. So if you are going to cut it, you will get around, I am using calculator, 2.18 into 10 to the power minus 5 meter. That should be your answer. Another question, a potential barrier of 0.5 volt exists across a PN junction. If a depletion layer of this length 5 into 10 to the power minus 7 meter wide, what is the intensity of the electron? An electron and with the speed 5 into 10 to the power 5 meter per second approximate the PN junction, approaches to PN junction from n side, with what speed will it eject from p side? So first part, E is equal to V by D, potential difference by D. D is the thickness of the depletion layer, that is 5 into 10 to the power minus 7. So that comes out to be 1 into 10 to the power 6. 1 into 10 to the power 6 volt per meter. That should be your answer, first part. Second part, we have to use the law of conservation of energy. That is your initial energy is equal to total output, total final energy, half mv1 square is equal to small e into potential difference, that is the energy, plus half m v2 square. That comes out to be, if you are putting the value, m is the mass of the electron, that is 9.1 into 10 to the power minus 31 kg, and that comes out to be, and if you are going to put the value, and you will get the V2 is equal to how much? Just to calculate. I am using the calculator, 2.7 into 10 to the power 5 meter per second. That should be your answer. Third number, a 2-volt battery may be connected between A and B. Assume resistance of each diode is 0 in forward bias and infinite in reverse bias. Find the current supplied by the battery if positive terminal of the battery is connected to A and B. This is a diagram. We know the diode works only in forward bias and it does not work in reverse bias. So A terminal अगर जब पॉजिटिव हो रहा है तो पॉजिटिव टू पॉजिटिव फॉरवर्ड बायस, ये ट्रायंगल वाला पॉजिटिव और वर्टिकल लाइन निगेटिव, राइट. तो यहाँ पर फॉरवर्ड बायस में करंट पास करेगा एंड द रेजिस्टेंस इज 10 ओम and then we have to find the current. So current means I is equal to V by R. V is given something volt, so V by R only. So how much is the V? R is 10, V is your, so I is equal to V by R. V is your 2 and 2 ohm, 2 volt and 10 ohm is the resistor. So 0.2 ampere is your answer. That much amount of current is going to flow. So you remember diode works in forward bias, that is switch on, and diode does not work in reverse bias, that is switch off, because of the resistance.